welcome to my channel Make Progress 2.0. Today our topic is transportation model. It comes under the subject quantitative analysis for business decisions, or you can consider it in operations research as well. So this transportation model is a special case of LPP. LPP is linear programming problem. So it is a special case of LPP. In this transportation problem, you'll be having different sources and destinations. The main objective of this transportation model is that to transport a product or any item from various sources to destinations. So in this, the main motive is to minimize the total cost. So to transport a product from various sources to destinations at total minimum cost. This transportation model is very much important for businesses to take effective decisions and to gain profits. So in order to have the minimum transportation cost, we will be able to solve by using two solutions. And first of all, let's see what are the types of transportation models. So here you have two types of transportation model, where one is balanced and the other is unbalanced. So if you consider, if a table or column is given in which each box is called a cell, below they'll be giving you demand and supply in the column 2. Here they'll be giving you the cell values. So these cell values represent the cost from that particular source to that particular destination. And here if the demand and supply values are given, for example 10, 20, 30, 50, any values. So if you had to check if supply is equal to demand, you have to add all the total values of supply and total values of demand. Here it's not equal since the values are different. So if you add these two, you'll see that the supply is not equal to demand. So you can say that this transportation model is unbalanced. So you have to balance the transportation model, and only then you should do the solution. So for doing the solution of transportation model, there are two phases. First one is initial basic solution. It is initial basic feasible solution, IBFS, and second one is optimal basic solution. So in the initial basic solutions, you can do it by using three methods. First one is northwest corner rule, and the second one is least cost method, or you can say it as greedy method. And the next one is Vogels approximation method. You would say it as VAM method as well. And coming to optimal basic solution, you have two types of solutions you can do by using two methods. First one is stepping stone method, and the second one is modified distribution method. You would say this as MODI method as well, or you can say it as UV method. So these are the two solutions for a transportation problem. So by using these methods, you could arrive at the solutions. So let's see today about the northwest corner rule. So what we'll be doing in this northwest corner rule, we have to find, in this we'll be knowing the total minimum cost of that particular transportation. So first question is, find the transportation cost using the northwest corner rule. So below they'll be giving you the table, which consists of a number of cells in between the rows and columns. So let me draw the table in the question. So these are the columns you have and rows. So the above you'll be writing them as destinations, and left side these are the sources, and you'll have supply and demand values as well from that particular source to destination. They'll be giving the cell values. Okay, fine. Now the supply 40, 60, 50, demand is 20, 30, 50, 50. So they'll be giving you these all information in the question. So let's go for the solution now. So if you go for the solution, from the table, if you observe, we have to check if supply is equals to demand. So let's check 40 plus 60 plus 50. We should add the supply. We got it as 150. S is equals to 150, and D demand is equal to 20 plus 30 plus 50 plus 50. So 50 plus 50, 150. So here the supply is equals to demand. So since the transportation model is balanced, we can proceed with the solution. So we can use here northwest corner rule since the transportation is balanced. So first of all, we should identify which is the northwest corner cell. So if you observe the northwest corner cell first, then you could do the problem very easily. So here in the question, the first cell which I have marked is the northwest corner cell. So let me show you the directions. You have east, west, north, south. So this is the northwest direction. So that corner cell should be considered in the northwest corner rule. So this is the northwest corner cell. So consider that. Let me redraw the table again in the solution. So they have given 3 rows and 4 columns with the cell values, all these, and supply demand is given. Here are the sources and their destinations. So let me mark the rows and column numbers as 1, 2, 3 and 1, 2, 3, 4. So while solving it would be easy for me. 20, 30, 50, 50, 40, 60, 50. So everything is given in the questions. Just I mark the rows and columns. Now we have to consider the northwest corner cell, that is the first cell, and you should check supply and demand, which is less. 20 is the least one, 40 is greater than 20. So you have to subtract 20 from both supply and demand, that is 20 minus 20 is 0, 40 minus 20 is 20. So in the north corner cell you will be writing 20. So since this column is 0, we have to delete the column 1. So which will become 0, that row or that particular column is deleted in the next iteration. So by redrawing the table again, by deleting the column 1, so now we will have only 3 columns, 2, 3 and 4. So 6, 8, 8, 8, 6, 7, 7, 6, 8. So I have written all the cell values. Now supply and demand side. So these are the column 2, 3, 4 and 1, 2, 3 rows. Demand. So what is supply? 20, 60 and 50. Demand is 30, 50 and 50. So 30, 50, 50. So I have written everything. Now again consider the northwest corner cell and check supply and demand. The supply 20 is less, so write 20 in the northwest corner cell and subtract 20 from both supply and demand. 20 minus 20 is 0, 30 minus 20 is 10. So we have to delete the first row. So now delete row 1. So let me redraw the table again. So by deleting the first row, I am redrawing the table. So I'll have only 2 rows, 2 and 3, and only 3 columns, 2, 3, 4. Since we have deleted first column and first row, so 2, 3 and 2, 3, 4. These are the columns. Next, writing the supply value 60, 50, 10, 50, 50. This is supply and the horizontal is demand. So now again considering the northwest corner cell, check demand and supply. Demand is less, so write 10 in the northwest corner cell, and 10 minus 10 0. 60 minus 10 is 50. So since the column became 0, delete the column 2. So deleting the column 2 and redrawing the table again, you will have column 3 and 4. So you will have 2 rows and 2 columns, 6, 7, 6, 8. So you have got this table, and northwest corner cell again considered. Both are equal, so 0, 0. So you got 50 in the northwest corner cell. So since the row and column became 0, 0, we have to delete both the row and column. So delete row 2, that is second row, and delete the column 3. Delete both column 3 and row 2, that is second row. So deleting that, we'll have only one digit, that is 8. Supply is 50 and demand is also 50. So considering the northwest corner cell, you'll have 0, 0. So finally we have reached the optimal solution. Finally, now to find the total minimum cost, we have to just redraw the table again by considering all the northwest corner cell values. So redrawing the table again with 4 columns and 3 rows, how it is at the starting of the problem. So all these values are given in the question. So we got the northwest corner cell values, so check them and write down. So we have numbered the columns as 1, 2, 3 and 1, 2, 3, 4. So since the first one is 20, I have written 1, 2, 3, 1, 2, 3, 4. I'm writing this. So next at 6 it is 20, and again at 2, 2 it's 10. So 2, 2 it's 10. At 2, 3 it's 50. 2, 3 it's 50. So here I haven't written the column and row number. This is 3, row 3 and column 4. So at row 3, third row, fourth column, you have to write it as 50, northwest corner cell value. So we have to multiply the northwest corner cell value and the particular cell value. We'll get the total minimum cost. So total minimum cost is equal to 20 into 4 plus 6 into 20 plus 10 into 8 plus 50 into 6 plus 50 into 8. So multiplying them and adding, you get 80 plus 120 plus 80 plus 300 plus 400. So if you add all these, you'll get 980. So total minimum cost, it might be in units, maybe rupees or dollars and anything. So finally what we have learned in this is transportation model. It is a special case of LPP. It should be balanced to solve it. So we had to check for supply and demand. So we have initial basic solution and optimal basic solution. So how we have done is we had to check whether it is balanced or not, the transportation. So then apply the northwest corner cell method. You have to consider the supply and demand and writing that particular least supply or demand value in the northwest corner cell. And as I have explained everything, finally we have to redraw the table again so that it would be clear for us to multiply them and find the total minimum cost. So we got the answer as 980 units. For more videos, do subscribe our channel. Please do like, share and subscribe.